Yeah, I think initially when we first introduced ourselves as a company, initially at Rapid, probably 4 years ago now, people didn't think we would be around for another 6 months.
Okay.
Small
That's a little
company.
harsh.
Yeah, it is. People are saying, you're a new company. You got something kind of cutie here, cutesy, but we're not going to see you in 6 months here. You just
Hmm.
aren't going to survive. I think it was establishing credibility because, as you said, I mean, GE is in this with GE Additive, EOS, SLM, Renishaw, Trump. I mean, a lot of good, strong, large companies. And the way we've kind of approached it is we have a unique way to make the technology more accessible, which we believe allows more people being able to enter into that space in order to see the benefits.
Hello there, Internet. My name is Adam Fosnot. I'm a mechanical engineer, and I have been working with 3D printers of all shapes and sizes for over 7 years. I've worked with machines from under $200 to over $200,000, and I have learned so much in the process. One thing I noticed is that a 3D printer tends to be judged on two extremes, one being a press release where everything is shiny and perfect, and the other being a YouTube review where a lot of times every product gets criticized. Another insight is that there tend to be two worlds in 3D printing, one being the industrial space and the other the hobby space, and those two worlds rarely talk to each other. This podcast breaks down those barriers to have a transparent, no BS conversation about the world of 3D printing and technology. I'm so happy to have you on board. Let's get started. Dave, let's kick things off. Could you introduce yourself to the audience?
Great. Yeah, thanks, Adam. Thanks for the invite to chat with your audience today. I'm Dave Jankowski. I'm the commercial operations leader for Xact Metal. We are a metal powder bed fusion solution designer, manufacturer, and provider on a global basis.
Awesome. And I'm really excited to get to talk to you because metal 3D printing, from what I can tell, is on such a rapid growth track within the industry. So I'm super excited to dive into everything. Before we do that, could you share something about yourself kind of outside of what you do for work to help the audience get to know you better?
Yeah, I'm kind of I like to exercise and fitness. I actually, pre-COVID, I was running about 6 to 8 half marathons on an annual basis. And then every 3 to 4 years, when I really got bored, I would train for a marathon. So I just enjoy the challenge. I enjoy the solitude. When I'm out running, I tend to kind of get my thoughts together. And I have a daughter who's 37, and she runs some of them with me. So that's always a
Okay,
special time.
definitely. That is super impressive. I think the furthest I've ever run was a 10K.
Okay.
And it was back in my prime when I was super fit from wrestling, and that was enough. That was enough for me. I've heard other people be like, "Oh, it's so rewarding," and you get the runner's high, and I maybe someday, but for right now, I can't get myself into it.
Yeah, it's just enjoyable for me to get out into nature and just enjoy. So,
Yeah, no, thank you for sharing that. I did go on a jog earlier today, but
which is good.
I maxed out at like 15 minutes, and then I'm like, that's enough. That's enough for me. Um, but gotta get the body moving somehow. If I'm at my computer doing 3D modeling and stuff all day. Um, so if we kind of refocus on Xact Metal, the company hasn't been around that long, from my understanding. And when did you start to get involved with them?
Yeah, that's a good point. We're about 4.5 years old
Okay.
as a company. The company was started by three individuals, two young engineers out of Penn State, who had a novel idea to direct the laser in a traditional metal powder bed fusion printer. So they had this great concept, and then they met a colleague of mine who had left GE. He He was a senior executive at GE, a gentleman by the name of Juan Mario Gomez, who was looking to kind of do something on his own. So he met these young engineers out of Penn State. We're located in State College, Pennsylvania, home of Penn State University. And at first, he was kind of mentoring them because Juan Mario had a lot of business knowledge, business background. And then when he started to kind of look into the technology and into the market, he realized that the technology these brilliant young engineers had developed would allow the manufacture of a metal powder bed fusion at a very accessible price point. And it allowed to develop a platform going forward. So they decided to team up. They formed a company 4.5 years ago. First couple years were really focused on finalizing the initial product. I joined Xact Metal. It'll be 3 years in June. I'm a retired GE executive also. I had known Juan Mario from my previous life at GE. He had reached out and I did a little bit of due diligence. I attended Rapid that year, went down to Dallas-Fort Worth. And frankly, the excitement when I walked through the door was just mind-blowing.
Okay.
I also realized that when I walked in the door, I probably raised the average age of everybody in the room by about a year. But just the excitement around additive in general, and as I've learned over the last 3 years of really participating in it, I mean, it is not only a super cool technology, but just the application space grows so quickly, and the solutions that can be provided just benefit everybody. So it's been a nice journey as I've kind of learned the technology and learned the market space.
Okay. That's really cool. GE obviously is a massive player in additive, specifically additive for metal.
Yep.
So I would imagine that you and Juan coming on board would just give a ton of value for these younger engineers who had kind of just barely gotten the ball rolling.
Yeah, and actually it's a great combination. There are 3 of us now who have GE experience from the leadership role. Juan Mario is the CEO. We have a gentleman named Mike Harsberger who leads our supply chain team. He had many years at GE running large supply chain organizations, and I came in to manage the commercial side. So as I tell folks, we may not be the smartest folks in the world, but we've kind of have been there and done that, and we've kind of learned from our mistakes. And then we're surrounded by this incredible cadre of just young engineers out of university who is just mind-blowing, their maturity and their technical knowledge and their comfort level dealing with all different levels of individuals. So it's a great combination where frankly they push us and we push them, and the result kind of shows itself in our final solution portfolio.
Yeah, it sounds like a really cool team dynamic there. Sometimes I worry that and I guess to some extent in previous engineering roles, a lot of times the younger engineers don't get along with the more experienced engineers and they butt heads about doing things one way or another. Um, so it's cool to hear that you guys have a really collaborative dynamic.
Yeah, it's nice. It's again, we're still a small team. We're 15 people,
Okay.
and every individual obviously is very critical to supporting the end user and to the growth of your organization. And it just, as we say, we love for folks to visit us
Okay.
because when they meet us, when they see the solution, and frankly, most importantly, when they meet our team, and I'm talking the entire team from the assemblers of the product to our engineering team to our applications team. They're just blown away by not only the knowledge of the individuals, but just by their overall competence and their confidence.
Yeah. So you have a team of 15 people, which is still very small,
Yep,
relatively speaking, especially
of
compared to
course.
these really big 3D printing OEMs. And you mentioned that you do pretty much everything in-house. I guess how much do you do in-house versus outsourcing versus locally? Can you give us
Sure.
an idea of that? Hey there, real quick. If you are enjoying this episode, could you do me a favor and subscribe wherever you might be watching or listening? It's totally free. It helps you not miss new episodes when they come out every single week. It tells the internet algorithms to help our content reach more people, and it would really make my day. I hope you think about it. Thanks.
Yeah, that's a real good question. I mean, we do all the engineering in-house, obviously, with our engineering team. The manufacturing is done as our facility here in State College. We, of course, source a lot of metalwork components outside, but frankly, we try to, keep most of our suppliers within about a 4-hour drive.
Okay.
Our laser is sourced in the U.S. So and then we assemble the final product here in State College. We start off with the sub-assemblies. We assemble it. We like to quote, pre-COVID, we were quoting a 8-week delivery.
Okay.
Now it's eked up a little bit just based upon the difficulty of some electronic components.
Mm-hmm.
But frankly, everybody's here. This is where our applications group is. This is where we're all based. We might end up having 1 or 2 folks based outside the State College just based upon their function and so forth.
Okay. Yeah, I think from a handful of other people that I've been able to interview, they talk a lot about sourcing things within the United States. Um, Especially something like a laser tube, I imagine is really difficult to find, both in terms of quantities that you might have to order and pricing and all of that. Um, is that an area that you're very involved with, or is that someone else's role?
That really is on the manufacturing side. But, we tend to, we source in the US, not because it's the US, but just because of the accessibility and the quick deliveries and being able to respond quickly to revisions and derivations and so forth. So that's kind of a direction that we initially went in. And so, pretty significant percentage of our printer is sourced and built within the US.
Okay. I think I met a couple parts of your team at AMUG a couple years ago. And at the
Sure.
time, there was one printer.
Yep.
Is it still one printer? Do you have a couple different models at this point? And kind of what are the differences between them?
Sure. Our core product is called the XM200C. C as in Charlie. It uses a high-speed XY gantry system to direct the laser onto the build area. That's what kind of makes us novel and differentiates us from some other manufacturers of metal 3D printers.
Okay.
The C is what we call the base version. We have a performance model that has a higher energy laser, an extended feed cylinder, and what we call fast parameters that allow us to increase the printing speed. And then we have a reactive model for printing not only non-reactive metals, but the reactive metals, essentially aluminum and titanium. So,
Okay.
and you look at the printer from the outside, they all look identical, obviously, but there are some very subtle internal changes that allow us to progress through those models.
Okay. Cool. You brought up aluminum and titanium. Um, so that brings up to my next thought of what materials are you doing today? Um, and I guess what does that material roadmap look like for you?
It's
Where
got,
do you see more opportunities?
yeah, we, started off 2.5, 3 years ago with the basics, 316 steel, Inconel 625, 718. We're getting into a tool steels now with M300. A little bit more challenging to print than conventional stainless is, but we're having
Mm-hmm.
success there. We actually hit a milestone about 8 months ago. We had a request to supply a printer to print copper,
Okay.
not pure copper, but 99.8% copper. And it was a learning experience for us. We thought we had the correct design for it. We realized that a couple areas had to be modified to handle the high reflectivity of the copper.
Okay.
And we successfully, were able to print copper, and we were able to incorporate those changes into our base printer. We're looking at cobalt chrome for some dental applications.
Okay.
Dental is a little bit more challenging for us, I think, just because we don't understand the market space as well. And there are a lot of other good entrants into that area. We're looking at other tooling type steels, doing some development work there. And then on the reactive side, we're really focused on titanium first.
Hmm.
Aluminum, we personally believe, may be a little bit of a hard sell with additive because, as we all know, aluminum is inexpensive and fairly easy to machine. So because of that, we said, let's get titanium nailed.
Hmm.
And we were real happy with the results on titanium. And then we're going to be starting on developing the printing parameters for aluminum, in early May.
Okay. That's exciting. So definitely not sticking with just one or two stainless steels,
No,
but really expanding it out, what sounds like
yeah, it is.
pretty
It is.
aggressively.
Yeah, it is. We actually have a materials engineer on board who that's what he does.
Okay.
He optimizes the printing parameters. We have a pretty established design of experiments on the way we do that. And then once we optimize the density, which is how we kind of determine if we have adequate fusion and adequate properties, then we go full bore and do all the mechanical properties to
Okay.
kind of, finalize the printing parameter data sheet.
Gotcha. And when you say density, could you define that a little
Sure.
more precisely? Hey there, it's Adam. If you're enjoying this video, could you go ahead and tap the like button? It's totally free for you, and through the magic of internet algorithms, it will help more people see the podcast. Thanks.
100%. We look at a relative density to what a forged or wrought density would be. We target to be 99.5% or higher as printed. Once we get to that level, we check that box, and then we move on to the next material.
Okay. Um, the reason I ask is because in some of my past conversations with people about metal printing, density is one of the most hotly debated topics of
Yep.
what's acceptable, what isn't acceptable, casting versus wrought versus extruded. So thank you for kind of clearing that up.
Yeah.
Um,
Yeah,
had a
the whole thing about and we've kind of learned on the side there, what really in our mind determines acceptability or mechanical properties.
okay,
But as you print, obviously, what you can more easily measure is the density. So we actually print density cubes. We invested in a specific solution and instrument that allows us to measure density very quickly. And we know once we achieve that 99.5%, frankly, the hardness, the tensile strength, ductility, and so forth, those properties just kind of follow along.
okay.
So that's kind of where we latched on in 99.5.
Gotcha. Okay. That's a really nice insight, I think, for anyone looking at some of the specific mechanical properties of printed parts. When customers come to you, what are they trying to accomplish with your equipment?
Yeah, that's a great question. It is kind of interesting because we've seen as our presence in the marketplace has grown in time and in space that folks are reaching out to us more and more. They typically come from two different angles. One
Okay.
angle is, look, we're experienced in additive plastic printing, and we understand the whole designing for additive, which is a plus, right? Now we want to expand into making parts out of metal, specifically maybe for benchmarking, for very low volume on the terms of, 10 to 20 parts per day at the very most, small
Okay.
parts. Tooling's a big one, obviously. So they come and they say, we want to kind of expand out of plastic additive into metal additive. Talk to us about that. And they look at the wide range of metal additive solutions, whether
Hmm.
it's metal powder bed, also called SLM and so forth, or FDM metal and so forth. So they kind of look at the entire range. The other direction is folks who really don't have any additive background previously, but they've heard about it. Maybe their son or daughter in high school is using a plastic printer, and then they
Okay.
hear that they can print metal parts also. So they might have an idea for tooling, for example, is a great example. They've been machining parts with CNCs forever, and now they start hearing about metal additive, and they hear it might give them some benefits on some unique design feature characteristics. And then they kind of reach out that way. So we discuss the options and whether our solution is the best, and perhaps it is, perhaps it isn't. When it is, then we can kind of follow through and print benchmarks for them and see if it meets all their other criteria in terms of financial viability and so forth.
Okay. And I guess I'm assuming that these are typically industry level clients, prospects. Um,
Correct.
so larger companies, I'm guessing over 50 employees. Um, are there specific industries that stick out to you more? Like, is it very heavy in automotive, very heavy in aerospace? Is there any insight you can give us to those areas?
We've actually sold across a range of industries, whether it's automotive, aerospace, medical, general industrial. Workforce development is real big now in education and so forth. And we kind of structured our approach in that direction initially. But what we found out, it really comes down to the application focus. For example, I mentioned tooling and machine shops.
Okay.
That ranges across automotive, aerospace, medical, and so forth. And so when we look at that application, the discussion that we have is, you know, can we quickly, efficiently, and affordably make the components that the end user wants to make rather than machining them?
Hmm.
What are some other advantages of additive in terms of speed of doing multiple generations and quick design pivots and so forth? So we're kind of evolving into the kind of this application focus where toolings has a lot of applications. Folks who want to do this or add metal additive to their plastic additive portfolio. And the third is education and workforce development. We're seeing a lot of interest
Okay.
in technical schools, 2-year colleges, and workforce development programs funded by state governments, where they want to take a worker perhaps who's been a machinist forever,
Hmm.
and now he wants to diversify his tool set, and additive is one of those diversification tools for him. So those are kind of the three big personas that we've kind of latched onto here over the last about 6 months. And the beauty is that covers all of the industries that we've talked through. So it's more of an application persona focus rather than kind of an industry focus.
Gotcha. I think that's a nice way to kind of look at your audience, is kind of honing in on applications versus solely we make a printer for medical or we make a printer for oil and gas,
Yep,
right?
yep,
I think it's just a little more targeted where you can
yep,
focus on the results more. So I really like
correct.
that.
Good,
Um,
good.
when you look at the one audience that you mentioned that comes to you, they've been machining things forever, but aside from seeing a printer at the library, they know nothing
Yep,
about 3D
yep.
printing. How do you kind of get them up to speed with designing for additive and the differences in the process? And I guess because in some of my past experience, that can be a really difficult conversation.
Do you want to be a guest on this podcast? If so, go to 3dprintauthority.com/forms to apply. Thanks.
Yeah, it really depends upon the organization. I can give you an example. We just had a terrific discussion with a leading injection molder up in Pennsylvania, where we're based at.
Okay.
And they've been making molds and dies for their injection molding process for over 40 years.
Okay.
and they know machining. They know, how to design most efficiently for CNC. But they've kind of run into the situation where there are certain features which they want to be able to include, which are very costly to include if they just manufactured via subtractive machining or CNC type work. So they hear about metal 3D printing. They see that you can make conformal cooling channels easily in metal 3D printing. And they say, man, that's good because it's tough to make those with conventional CNC type of processes. So we have a discussion with them, and frankly, the designing for additive aspect doesn't take that long because most of these folks, if they've been around programming a CNC for a while, I mean, they're super sharp. They understand metal processing. So the designing for additive more is just explaining the capabilities, and they get it very quickly. We actually find that folks who are comfortable processing metals, whether it's a machine shop, welding, powder metal coating, metal mold making and so forth, if they're comfortable with metals, really isn't a hard addition for them to move into metal additive. A little bit of software stuff, but it's pretty straightforward. So this metal comfort we find, is very important. I mean, a couple of things to point out is with metal powder bed fusion printing, the part you make is physically welded to a base plate that you build it on, because
Okay.
metal powder bed fusion is a micro welding process. So you have your part. Let's say it's a number of fingers for a robotic arm. They're physically welded onto this plate, and then you have to remove them from that plate. You talk to somebody who has a machine shop or is experienced with machining, it's not a big deal. You say,
Right.
okay, I'll just put it on my EDM.
Hmm.
Let's talk about something difficult, Dave, right? Where you talk to somebody who perhaps doesn't have that metals background, it's a little bit more of a little bit more intimidating for them to kind of get comfortable with
Hmm.
that. So we find folks with metal background combined with perhaps maybe the same organization who has some plastic additive experience, the transition to add any metal-based 3D printer, you know, isn't really a huge jump. It really isn't.
Okay. Yeah, I really like that uh, feedback kind of from your personal experience. And as I think back from my past experiences, I can see how that makes a lot of sense. So just to kind of reiterate, and I'll have you agree with me or disagree with me.
Sure.
If a company is regularly processing metals, they're already cutting their own molds, they're already CNCing their own prototypes, they're making their own jigs, fixtures, tools, then metal additive isn't going to be a giant step for them. On the
Correct.
opposite side, the company that outsources all of their aluminum prototypes, hypothetically locally, a company that hasn't cut their own injection mold in a year, they're going to struggle a lot more. Is that
Yep,
right?
that is correct. I mean, as our printer, as with other available printers out on the market, everybody strives to make the interface to the instrument very simple.
Mm-hmm.
And so, which is good. And we find that most folks actually pick up the operation fairly quickly. It's kind of the other stuff. It's the post processing. It's the, getting their mind shifted, designing for additive versus designing for subtractive type of processes and stuff. So we find metals folks can make that switch very quickly. Folks who don't quite have that metals background struggle a bit more. On the other hand, if they're used to doing plastic additive, that provides a little bit of value too, because a lot of the software that is used to generate the build file is very similar between plastic and metal additive.
Yeah, that makes a lot of sense. I'm gonna pivot a little bit here. One of the biggest areas that I think people get concerned about um, is metal powder handling
Yep,
when looking at powder bed fusion printers, even if it's a nylon SLS machine or but especially with metals because they can
sure.
be dangerous to handle. How do you guys address that?
Yeah. Well, it's, that is front and center. What we always discuss is once, we or one of our sales partners has a first or second level discussion with a possible end user, we say, let's get your EHS folks involved. Let's just kind of talk through what you have to be aware of with handling metal powders. For non-reactive powders, which are steels, coppers, bronzes, inconels, and so forth, everything except aluminum and titanium, what we call non-reactive metals, the steels and so forth. The concern is you don't want to inhale the powder accidentally. So even though the metal powder is more dense than air, so it settles to the lowest point within the room,
Mhm.
you still are required to wear a respirator just to ensure you don't inadvertently inhale the powder. We also recommend gloves because you don't want to track any of the powder, perhaps back home with you when you head back home. And we really find that those two plus general housekeeping really eliminates, the majority of the concerns about handling a metal powder. You still have to be aware of it, obviously. Um, typically when people load the powder into our machine, it's about a 3 to 5 minute process. Then
Okay.
once the lid is closed, you don't have to wear your personal protective gear anymore. And then when the print's completed, it takes about 15 minutes to unload the print and then to prepare for the next print. So, I mean, in a total build, you're talking probably 20, 25 minutes. They have to be very acutely aware of that. There is a metal powder. Anyone within 10 feet of the printer has to wear a respirator. If you're back more than 10 feet, you're not required. So you just have to be aware of it. When you start working with reactive powders, such as aluminum and titanium, by reactive, we mean, when it's exposed to heat and oxygen, there's a chance of perhaps a fire. You have to take more stringent requirements, not only in the handling of the powder, but also in the facility which you install the printer in. And we often find the facility to house a reactive printer is frankly more costly to build than the printer itself.
Okay.
Non-reactive, on the other hand, can we put adjacent to a machine shop, for example? Or can we put in the same room as plastic printers, as
Okay.
long as you map off that 10-foot radius around it? So there is a distinct between the two. Safety, of course, is our number one focus. We train on safety when we do the installations. And you just have to be aware of it. You don't have to be afraid of it. You just have to be
Mhm.
aware of it and take the proper safety precautions.
Yeah, that's a really interesting distinction because the facilities requirements are always a concern when you're going to bring equipment in-house in a business. There's a level of liability there.
Correct.
Um, so from your point of view, the biggest distinguishing factor is what material you're printing. Is that right?
Correct. That is correct. In fact, what we typically recommend is we get a lot of phone calls and inquiries on printing either aluminum or titanium. And we have the discussion with them. And we always recommend, we say, look, even if a year from now you want to print titanium, start with something easy.
Okay.
Start with 316 steel, get comfortable with the designing for metal additive, get comfortable with the machine operation, and kind of practice on that before you move to the next level, which is the reactive. And that tends to more times than not, is what occurs.
Okay.
You just want to practice and get comfortable with how things come together and what to kind of look out for. And then they're moved, up to the reactive metals.
Yeah. Um, That seems like really good advice to a customer if they're kind of new to the additive
Yep.
side of things. They're not already running a DMLS printer or something like
Yep.
that.
Yep. 100%.
Something I just thought of, and I'm really curious about from an offering standpoint. Two things that I think often come up when people are thinking about higher-end equipment. Do you guys offer printing services on a for pay basis? And two, do you sell direct to customers, or do you go through a distributor network?
Do you have a question about 3D printing? If so, I would love to answer it. Feel free to leave any questions in the comments down below, or go to 3dprintauthority.com/forums to submit your question. Thanks.
Yeah, good questions. We, on occasion, will offer printing services if somebody wants to print 12 of something, but frankly, if possible, we kind of recommend printing bureaus to kind of do that
Okay.
because they're probably more set up to handle those jobs in terms of, their whole financial model and the speed to print them and so forth. But we do it. We have a print job going on right now, right? In terms of how we sell and support the printers on a global basis, we're firm believers of local regional support.
Okay.
Right now we have 27 sales partners covering 52 countries, and which means that probably 60 to 70 different languages.
Yeah.
And we believe in local application support, local pricing support, local service. So, for example, our sales partner in the Nordic region, quotes in Swedish, Danish, Norwegian, Finnish, and they have support teams to support the printers during the installation and then the post-installation service support.
Okay.
So, we've just adopted that philosophy from day one because, frankly, somebody in Japan wants to be serviced by somebody in Japan who speaks Japanese, who quotes in yen, and they don't want to be 12 hours out of time sequence to dealing with some person in Pennsylvania. So we're just very committed to this, the strength of having a local and regional sales partners on a global basis.
Gotcha. That's always something that has confused me a little bit, I guess, about the industry. Are there any other outside of time zones,
Yep.
local language service support? Are there any other advantages that you see to that model? It's just an area of interest for me.
Yeah, no, frankly, our sales partner in Germany knows the German market. He has an established set of customers.
Okay.
He knows how to sell and support within the German market a lot better than we do. And so they just provide tremendous value there. I just think the language is so important. As I mentioned, our partner up in the Nordic region, he has to be able to invoice in 5 different currencies.
Okay.
For us to be able to do that and do it globally, it just wouldn't make any sense, frankly. And our key metric is really supporting the customer real time because that's so important. And having these regional support partners, these regional sales partners, really allows us to do that.
Gotcha. Okay. Thank you. When you look at this journey you've had so far with Xact Metal, is there anything that jumps out to you as the biggest challenge you guys have faced?
Yeah, I think initially when we first introduced ourselves as a company, initially at Rapid, probably 4 years ago now, people didn't think we would be around for another 6 months.
Okay.
Small
That's a little
company.
harsh.
Yeah, it is. People are saying, you're a new company. You got something kind of cutesy here, but we're not going to see you in 6 months here. You just
Mm-hmm.
aren't going to survive. I think it was establishing credibility because, as you said, I mean, GE is in this with GE Additive, EOS, SLM, Renishaw, Trump. I mean, a lot of good, strong, large companies. And the way we've kind of approached it is we have a unique way to make the technology more accessible, which we believe allows more people being able to enter into that space in order to see the benefits of metal powder bed fusion printing. So it's really establishing credibility.
Okay.
We are beyond that now. You know, people realize we're a credible company. We have financial stability. We're around here to stay, and we have a really strong product that, you know, can really help out the end user.
Right. Um, when you think back to those early days in establishing credibility, were there some key wins that you can point to that really moved the needle in establishing credibility?
I think it's a combination of those interpersonal relationships, you know, meeting folks, you know, listening to the end user, seeing what they liked and what they would recommend for improvements in our solution.
Mm-hmm.
From a sales distribution perspective, we had two or three of the largest Stratasys distributors sign on with us because they
Mm-hmm.
met us, they liked the people, they saw our vision. And that was frankly super critical within Europe and within the
Gotcha.
US,
Okay.
because again, that shows enhanced credibility. And then, of course, you know, releasing the product and making it on a consistent basis. You
Mm-hmm.
know, as Juan Mario, our CEO, says, anybody can make one offs or two offs. To make high quantities of the same product reproducibly. You know, we have CE certification, which allows us to sell over in Europe. We got CE certification when we were a 9-person company. A nine
Okay.
person company getting CE certification, which is non-trivial. So from Europe, of course, that was key for us. I would
Mm-hmm.
say really listening to folks, you know, sharing our vision, establishing or getting relationships with two or three of the top Stratasys distributors globally, and then, you know, getting a reputation for having a strong, consistent product and doing it over time. You know, I think that's what has really established us as a viable supplier of this technology.
Yeah, those are all really good points. I can relate so strongly to it's easy to make one or two of something. As soon as you scale up, it just the problems explode
Yes, they
exponentially.
do. Yes, they do.
But it's a fun challenge. I want to rewind just a tiny bit. You mentioned making it more accessible.
Yep.
Um, to break that down a little bit, a lot of times in a business sense, that means cheaper. Could you give us an idea of
Yeah,
the price range of your products compared to
sure.
what you know of the price range of other products using the same technology or
Sure.
similar technology?
Yeah. And again, I mean, that's when we use the term accessible, you know, we really are focused on a couple areas. Number one, you know, the price point. You know, price point varies from $90,000 up to $130,000 for the printer.
Hmm.
And then on top of that, you add about $35,000 for the peripherals, the software, the tools you need.
Okay.
So kind of all in, you know, 125 to, you know, $165,000, you know, which, you know, puts us at a pretty good price point, you know, in reference to some of the other suppliers of a similar
Hmm.
technology out on the market. Look, there are a lot of good high quality printers out there. One of the main challenges has been making it more accessible so other folks can afford to purchase it and to kind of decentralize it. What we found is that, you know, there are a number of $750,000 metal printers out there, which are great products. The unfortunate thing is they might be located in a central lab and you have 3 PhDs running it. And if a
Gotcha.
guy in their machine shop wants to use it, it's kind of difficult for him to get access to it.
Mhm.
So by making it more accessible, we think we've kind of found a good position in the marketplace where we're actually expanding, I think, the opportunities. I don't even think we're really competing that significantly against the other folks because they have advantages compared to our technology, just like we have advantages compared to their technology. So I really think we're expanding the marketplace here.
Yeah, I like that perspective. I think it's probably very true compared to, I think when you have such a different system footprint and price point, that kind of means you're selling to different people, and it doesn't mean that you're directly competing all the
Yep.
time.
Yeah,
They're
correct.
they're
Correct.
they're not better or worse. They're definitely different.
No, they are. They are.
And I think having lots of different offerings in the market is only a good thing.
And
Um,
I mean, even just compared to like, FDM metal type solutions, there's a place for those solutions and there's a place for metal powder bed solutions also. And I mean, the beauty is the end user really benefits by having those options because he can select what is best for his specific application.
I couldn't agree more. I think if you what is that phrase? Rising tide raises all ships. I'm
Yep.
butchering this badly. I know I am. But I think it really applies to what
It
you're
really does.
alluding to here.
It really does.
One question I've liked to throw in recently, if you look at 3D printing from all of your experience, what's one thing that you don't like about it?
What is
So
one
it's
thing I don't like 3D printing?
it's intentionally broad.
Yeah.
So
Yeah.
to give you some hints here, maybe you don't like that it's relatively slow. Maybe you don't like that there aren't hard established engineering standards. Maybe you think more 3D printers should be painted blue on the outside
Yeah.
instead of they're all
No.
black or gray.
No, I think that's a good question. I mean, what I've come to realize is some folks think 3D printing, whether it's plastic or metal, is the solution for all manufacturing. And it just isn't. I mean, as we talked about, if you want to produce 100 metal parts a day, I don't think metal 3D printing is the way to go. You can machine them quicker, right? So we really have to look at the applications. I think probably the one thing that I've learned is it isn't a panacea. That perhaps I thought when I attended that first rapid,
Hmm.
I thought it would replace everything. CNCs would be no longer required. Well, that's completely wrong. And then I think the speed, obviously, I think that's why you really have to discuss with the end user whether really 3D printing is appropriate for their application. Sometimes it is, and perhaps sometimes, other fabricating solutions are the best.
Gotcha. I like that. Focus on the application, make sure
Yep.
everyone's expectations are very clear, and then pick the best tool for the
Yeah.
job. It's
Yeah.
not a silver bullet.
No, it's not. And that's why the majority of our sales partners carry different metal solutions. We're the primary
Gotcha.
metal powder bed solution, but they could also, you know, sell a FDM metal type solution. And the customer says, I want to print this part in metal. What's the best way to do it? They can go in with multiple metal solutions and then help the customer determine what works best for their application. Because I think that's tremendous value to the customer. I really do.
Yeah. Excuse me. That makes a lot of sense. I've got one question to wrap things up. But before we get there, where can people find you? Where can they learn more about Xact Metal? And if there's any specific calls to action you'd like the audience to take next, now's your chance.
That's great. Again, it's, we're www.xactmetal.com. That's XACTMETAL. There is not an E in front of the X. My wife always asks me about that. I said, honey, they chose the company name before I joined. So
Right.
xactmetal.com. You can like us on LinkedIn and Facebook and so forth. But really do go check out the website. There's a real nice learning section of it.
Okay.
Even if you're not interested in our technology, look on the learn section. It kind of walks through and talks about the technology and so forth. And then really, if you're attending some upcoming conferences, which are starting to be held in person again, we'll be down at AMUG in Orlando in a couple weeks. We'll be at Rapid. We'll be at a wealth of shows here the remainder of this year, and you can find those listed on our website also. And just stop by and just chat with us. And look, we're a very transparent company. If we believe our solution isn't the best solution for your application, we'll recommend on who to talk to, because our real focus is expanding the scope of 3D printing for the right application for the right end user.
Excellent. I think more transparency is something that we can all get on board with. Final question for you is, outside of your products specifically, what's one thing that you're really excited about in 3D printing, whether it's a trend, a technology, or just something that you want to see more of?
I think some of the scanning technology that has been introduced in the last 10 years is mind-blowing.
Okay.
Just in terms of not only the quality of it, but then the post application. So I think scanning application or the scanning technology is super cool. I think looking at some of these more unique materials, we were recently contacted about a memory metal
Okay.
that would be. There are certain advantages with additive compared to conventional manufacturing. So I think enhanced materials also is going to really continue to open up this application space.
Yeah, that's a great answer. Scanning is so fascinating. And it's so often right next to 3D printing in conversation. So it's certainly worth looking into. Dave, thank you so much for taking the time to chat with me. And I'll look forward to connecting in the future.
Adam, appreciate the time and appreciate the folks listening. Have a good one.
Thanks.
Thank you so much for taking the time to tune into my conversation with Dave from Xact Metal. I really enjoyed the conversation, both learning from Dave's vast experience and learning more about what makes Xact Metal unique in the landscape of metal 3D printing. To learn more about what they have to offer, make sure to visit xactmetal.com. That's Xact, exact without the E.com to learn more. Be sure to subscribe to 3D Print Authority wherever you might be watching or listening. And to learn more about me and find the full video and audio only versions of every single episode, make sure to check out 3dprintauthority.com. Until next time, happy printing.